Okay. So whenever you're ready,
Yes.
the stage
The mic is
yours.
on? Perfect.
Thanks a lot.
Okay, if you guys are hungry, then this is probably not a good sign for me. But I'll try to make this good and relatively quick and hopefully entertaining. So my name is Julie. I've been making stuff on the web since 1999, and when I did this slide, I thought, damn, I'm old. I've done a lot of different things, and I started in high school, and back then it was just kind of a hobby, right? There wasn't any sort of, hey, there's conferences, and it's a major maybe now at different schools. And did a lot of different things, and most recently I actually joined the enterprise world where I also use JavaScript. So after failing at being an entrepreneur, I joined Allianz, which is one of the largest insurance companies in the world, as an enterprise architect. And that gave me a very sort of different perspective on software, especially microservices, that I want to share with you today. I started 2 months ago at Microsoft. They stole me, but Allianz is my customer, so I'm still kind of very much in that space. And the last thing I want to tell you, and you'll see this a little bit in my talk, is I'm a designer at heart. And a designer is not a creative person necessarily. A designer is somebody who solves problems with constraints. So, welcome to the cloud. How many of you deploy to the cloud, the public cloud? Nobody. Okay, I expect all hands actually to go up. We'll see. Wrong. There we go. So, when I first started, right, there was basically just a monolith, and everything lived on one server, on-premise, maybe in your parents' basement. Things got a little bit more complicated, especially as consumption sort of grew. And the web also changed. We have single-page applications. The front end, the browser says, I really don't need you back end. I can do everything by myself. Although we're going to learn later about server-side rendering on the back end. What really changed this was really mobile phones, right? Suddenly everybody had a little computer in their pocket. And then it became even more complicated as that usage grew, right? So the iPhone was amazing, but it really had performance problems. It couldn't make 100 API calls. And so that was one of the big incentives to actually have backends for front ends. Let's develop something that the back end really gives to the mobile front end. It's not just, okay, filter what you need, it's I'm creating this especially for you. Now for backend developers, it's kind of like, okay, what do we do now? What is our job, right? Part of it was split off, and they're kind of like gatekeepers of state. And this gets really complicated when you start thinking about microservices. And when you first start looking at tutorials, introductions, you see something super, super simple. Okay, I have an application, right? I have a main gatekeeper at the front, maybe you call it an API gateway. And then you have little domains. Super easy. You can just deploy these independent components. They're small, they're modular, and they're automated, and you have failures sort of isolated. It's not that easy, right? So if you own your domain, you also have a database. Chances are you have at least 2 components. At the Allianz, maybe a little service would have 10 components. Some have 2, but some have a lot. And to illustrate further how this can get complicated, let's just look at one particular service, invoices. If you're doing this sort of end-to-end, you're going to have a lot of different components. You'll even have messaging. Why do I have messaging? Because I want to generate a PDF. And if the worker fails to generate that, I want to retry it, right? Which is one pattern that's really important for microservices. But what I want to pose upon you right now is this is really, really complicated. It's super complicated. Another complication here is I have my own database for invoices. Why the hell would you do that? Well, Julie bought something 2 months ago, and she bought it at this particular price. And I'm referencing a product, maybe not, maybe I'm copying the product. You know, there are a lot of different tool sets that help us do this more easily today with NoSQL databases, but if you think about it, it's really complicated. And sort of consistency of your data is one of the biggest challenges that you have, especially in a large enterprise. So this is a graphic from Azure, and so, oh, introduction to microservices. This is the simplest graphic I sort of found. And you see, it's not that easy. And one thing that's really important to notice is down here, service discovery and service management. Nobody talks about that. What happens when you go live? What happens when you have not 1 or 2 microservices? What happens when you have 200 or even 20? And that was basically one of my jobs as an enterprise architect. And I was the only person, the only enterprise architect who knew JavaScript. So you get some really funny and random questions. And JavaScript is going enterprise. And it's actually pretty cool. I think we have unique sort of business challenges that we get to tackle. So it gets really complicated, and then suddenly it feels sort of like spaghetti, right? You suddenly have too many components, and are they really decoupled? Or do you really need something from somebody? Maybe you need data from somebody. Your service doesn't go down, but you have no value if nobody's talking to you. All right? Failures are super complex. Debugging is really hard. You have tools that sort of help you to do that. But still, it's like, what do I do when it's not there? Like, the debugging helps you say, I have a problem, but what if you're not there? That's something that I was really sort of focused on in my old job. And people think the cloud is always there, right? So this table is from Azure, and the cloud is almost always there. Nobody ever says 100%. And if you look at this table and think about it, 99% sounds great, right? But it still means almost 4 days of downtime in a year. 4 days is a lot. Are you preparing for those 4 days? And even if you're using the cloud, are you preparing for those 6 minutes? So earlier I said the Allianz is really, really big, and I worked for Allianz Germany, which had in 2018 2.4 billion in profit, which means actually if we put that over the calendar year, it means 6.5 million a day. So if we had downtime of a few days, that's like $24 million, which is a lot, or actually euros, I think. So that's why it's kind of like you really need to consider these problems. And if you think about it, you're working on one microservice, and you not being there or your service acting weird might affect another team. And that's kind of a funny challenge to have to deal with. So the first takeaway I want you guys to walk away with is the cloud is very complex. And it's not perfect, right? Nobody offers 100%, but that's because we're complex and we're not perfect. So architecture, right? Not just microservices, architecture. That's supposed to be my job. I do spend a lot of time sort of drawing diagrams. And I really like these sort of traditional diagrams, even though they become outdated as soon as you publish it, because it shows intent. What did you want to build? How is it supposed to actually function? And what are your dependencies? So in certain diagrams, I think this one actually indicates flow in terms of the arrows, but arrows can also indicate dependencies. These are very static, right? It's very pretty, but it's very static and very quickly outdated. So what if we did something with code, right? It's pretty simple to understand if we're just talking about intent. So I have them, I call them nodes. I'll tell you why later. But basically you have different deployable components, and you can also just manually define the links, right? And that helps you sort of do intent. Well, my colleagues would tell you, Microsoft already does that. The cloud does that for you. And it's not just Microsoft, you have various different tools that will automatically generate diagrams for you. And this is a very sort of small diagram. As somebody who's used to be a designer, I'm like, there's way too much information sort of going on. And one thing about these sort of automated diagrams is they rely on something, usually agents, trace agents. And at the Allianz, to make sure everybody used them, you put them in the base image of something. So every developer builds on the different layers and containers and whatnot. And guess what? If the agent doesn't work, and literally there was a problem where some package in NPM changed, or it was so new, it wasn't in the base image yet, and nobody using JavaScript could deploy. And that's a lot of people. It would surprise you, but that was a lot of people suddenly yelling at me and like, what am I gonna do about it? And basically the solution was to actually very quickly change the base image and remove the agent. And then suddenly you don't quite have your logging or debugging. And those are the kind of trade-offs you have to make and make in a larger organization. So one team's pissed off, their logging doesn't work quite right, but all the other teams that want to deploy, they can suddenly deploy. So I don't like automation. I think with automation, you have to be careful. It can also create sort of problems. And so this is another screenshot, and just, there's too many arrows. There's way too many arrows. And if you think about the number of components that the Allianz has, and this is from a community diagram, but imagine all the arrows drawing this, right? So first, the visualization takes ages to load, and it really doesn't tell me anything. It's just way too much information. And this is somebody actually asking in the Grafana community, I have my dashboard now. How do I connect all of this? Well, you really can't. So people build dashboards because they want to know what's going on in real time. Is my service, like, is it good, is it bad? I actually don't know. And the best thing about these graphics are if you're measuring sort of CPU usage, temperature, memory, you're in the cloud. You don't care. And that's why we're going serverless, right? You don't care. And you can optimize things and make the cloud usage cheaper, because obviously you're paying per usage. But if I'm making billions in profit, or even at a smaller scale, like honestly, saving $100 a month sounds like a lot, but think about how much do you make a day, especially as a freelancer. $100 or, for a month or a day? So what I like to do is look at things and think about, okay, what is actually the problem? And I saw this tweet yesterday and I loved it. There's basically a drill under something really super heavy, and if you pull on the cable, you can't pull the drill underneath the whatever loading bed. And actually there's a different way to solve the problem, which is you don't pull it from underneath, you pull it from above. And if you know how ropes work, and I'm a huge passionate climber, it's super easy. And you can see that he looped it through, and now he just pulls it over. And this was actually tweeted by, I think, Engineering World or something like that. But I saw it, and I was like, yes. So what is the real problem with microservices? The real problem is that we imagine people and organizations are monoliths. Everybody's sitting in the exact same room. All these developers somehow look alike. Everybody uses a Mac. Of course, everybody uses a Mac. But really, we're super diverse, right? We have old people, we have young people, we have men, we have women. And you even have the marketing guy in the suit. He helps a little bit, right? He tells you what's going on with the business domain. But it's really, really diverse. And so really, you should expect these problems. You think like, oh, yeah, we're just saying we want diversity. Well, why do we want diversity? Because with different perspectives, you can actually solve problems better. And so this is the first time I'm giving this presentation on a PC, and I'm like, please work, and it actually crashed during the previous talk. So really happy that it worked. But one thing I realized recently visiting China, from where my parents are from, is that we're really, really privileged. And it is an interesting experience to develop on a Windows machine. Not just to surf the web on a Windows machine, but to develop on a Windows machine. And one of the reasons why I wanted to try that was just sort of like, hey, if we're really going to talk about inclusion and diversity, let's see how the other side sort of lives and works. And so I still use a Mac for my personal usage, but I'm trying to use the Windows machine for work. So there's something called Conway's Law. And it basically says your IT system will reflect your communication system. So if you are in a giant enterprise that's very hierarchical, I can't say the word in English anymore, in nature, your architecture and your system will actually probably look very similar. The conclusion here is that computers are useless. They only give you answers, right? Technology is great, and they do a lot of things better than we do, but often has to do with they're faster, right? And you can tell them what to look for, and they can find it faster than you. But who's asking the question? We are. And I love this quote from Pablo Picasso. It really is, they're useless. They're only answers, but what is the question? So looking at those dashboards, being really super frustrated, and at the time I was still part of the Alliance, I was like, I want something different. I want something sort of better. I definitely want to have more dependencies between services. I don't necessarily want request flows. When you're using agents, you're going to get request flows because that's easier to do. I can't imagine a way to do intent without actually just sticking a human there. The other thing that I want to do, because why not, you already have the graph, is to include a little bit of sort of monitoring, include a little bit of sort of the health status. And then, so you end up with something that looks like this. It's a little bit of a graph. The colors I'll go through in a second. And the nice thing about this is I really want to get rid of all the clutter. Everything that doesn't tell me anything if this was hanging on a wall, right? So I'm not saying get rid of the trace agents. I'm not saying get rid of those awesome debugging request flows, whatever. It's just sort of, it's not useful in an everyday whatever, because hopefully you don't have to debug. Hopefully it works really well. So to build this, I didn't want to use a particular software agent, right? So like the Azure document, the graph that I showed you before, you need to be on Azure to use it. So I thought, how can I make this open and entirely cloud agnostic? So just use a health check. You need to have health checks anyway. When you're automatically scaling your pieces of software, the cloud needs to know how is your service healthy. Because I can just spin up 100 things, but 99 of them are dead. Or maybe all 100 are dead. And so basically the cloud always says, okay, is this good? Is this not good? So you have that probably built in anyhow. There's a standard from the IETF, which is the, I think, Internet Engineering Task Force. They define these standards, including for the web, so like HTML and stuff like that. And so it's actually pretty cool. When I first saw this, I was like, oh, there's a lot more things you can put in there. And instead of maybe pinging like, 5 components, I can just ping the main components, and in the details, I can get so I know the state of my database, etc. And so this is just a standard. It's not going to be a software, whatever. It's just, hey, here's a standard interface. Why don't you implement this? And so going back to what I wanted to create and sort of give it some sort of information and value is, all right, I want to show dependencies. So I want to add arrows, but I also kind of want to use colors, right? Because colors let you sort of interpret a lot of information without text and process it very quickly. A lot of people will create microservices, but really what they have is a distributed system. It's a distributed monolith. So in this example, just to illustrate what I wanted to achieve, especially in that case, you'll see there's something here called deep source. A deep source is basically a dependency of a dependency. Maybe you don't even know that that deep source exists, but I want to be able to sort of illustrate that. As you can imagine, enterprise, there might be 10 different or 20 different touch points, and the one at the end doesn't necessarily know about the one in the beginning. So kind of defined a little bit what I want to do. One thing I want you to take away with is also scratch your own need and make new things. Share as well via open source. I know we just heard about like maybe there's too many different packages. Well, maybe there's a problem that hasn't been solved yet. So let's make a new package. So I actually built something to do this, and some of these images are actually just screenshots. And I used d3.js to build it. So I used to do a lot of front end, but to be honest, I hadn't done any for years. And this was one of my first sort of adventures in front end again. And it was actually a little bit frustrating. And so I'm going to talk a bit about d3, and as well as sort of some of the mistakes, stumbling stones, and what I learned. I use d3 because basically it's the standard out there for creating graphics. It's really, really cool, and theoretically very easy to use. It's kind of like microservices. The beginning is super easy, the rest less so. The great thing about D3, and it stands for data-driven documents, is that you really don't care about the DOM. You don't need to be like, oh, let me find this element and remove it, or let me add an element here, or whatever. You literally just give it a structure, and it'll draw everything out for you. And it gives you a nice interface as well to add whatever you want to your elements. So I showed this a little bit before, the sort of structure that I wanted to use. And what's really important, and this was something that I tripped up on, was source and target need to be strings. And that's not really well documented in the D3.js. So I just was like, oh, I'm going to be lazy. I'm just going to use indexes and integers. Doesn't work. Use strings. And so a node is a component. And they have something called the update pattern, which I'll talk about in a little bit. But literally, you need to have a file that sort of sequentially has these calls. And then it sort of works. One thing that screwed me up is that you need to remove the ones you don't need first in the beginning. I don't remember what happens, but this is a long time ago on Thanksgiving or Christmas. But you need to do that first. And then it makes sense. Let me add new elements for the ones that I need. And at the very end, let's swap out the data and add the appropriate sort of attributes. So I just very quickly mentioned the general update pattern. The code is a little bit difficult to follow, but once you have this graphic, it's a little bit easier to understand, right? I'm going to remove this, and then I'm left with those DOM elements. And I really don't care which ones are new and which ones are old. D3 just basically updates the attributes for me. There is a newer syntax. It's about 5 months old. I wish it was there last Thanksgiving. I think it would help me. So you can sort of give it functions. I haven't tried it, maybe one day. So links, similar, general update pattern. One thing that really screwed me up, and it's, copy and paste, because everybody does copy and paste. Every DOM element still needs a unique identifier. You need to be able to identify, okay, I'm going to highlight this one, I'm going to do this to that one. And I had for the longest time, basically, I was just putting the ID. There isn't any sort of ID, and to be unique, you have to have actually both the source and the target there. And then For the first time, I used markers with in HTML to make the arrows. Kind of works. I don't really understand how, but it kind of works. We just had this slide, I think, right? Okay. So the next thing you need to figure out is then how do you arrange everything? So this is the default D3 engine. It tries to do everything in a sort of uniform way, which looks really nice, but as soon as it adds arrows, it's not very helpful. So there's another layout engine called Webcola, and it allows me to do sort of what I want, left to right, and you see sort of there the central point, the API gateway, which some people will say is a central point of failure, and it can be. And I wanted to basically hide all of that, because it's super, super complicated, and everything that you find about d3.js is unfortunately one really long file. So I was like, okay, I'm going to build a library out of it, and this is all that I want to have. Just throw in some data, create a graph, have some events, and theoretically you should be able to do something. And actually, this is online. It's already published, so I gave it a name. Well, it's published on GitHub. It's not published in NPM, because I don't want to, put some trash on it. It's a work in progress. It works for me. I don't know if it'll work for you. Play around with it if you think it's interesting. It's a side project and something sort of I'm just going to do going forward. And because I only look at it every few months when I have time, tests and documentation is very, very important. One thing you should take away from this, as like you should do this, and this is not me being a former enterprise architect, document everything and have tests. Because when you want to work on something later, you want to just know what's going on. And you don't always know from looking at the code. You just don't. So let's do a bit of a live demo. Go here, hit escape. There we go. Let's go back to duplicate. Yeah. So I need actually 2 different windows. And this one. There we go. So I have this sort of graph here. What's interesting to note, although the lines aren't as visible, is you have something here that's like a worker, and it doesn't really connect, and actually Cola throws it in the other direction. And that's just sort of a pattern. If that thing goes away, you won't necessarily notice it if it's a short period of time, because you have a queue and everything is just in the queue. And it'll be retried when the worker is available again and healthy. So that's something worth noticing. So what happens if something go down, and what can this do? And so I built a little animation. It's shaking. I want to shake the whole thing, but it wasn't as easy to do. The idea of this is, okay, the API gateway is down. Hey, front ends, be aware, it's down. Hopefully this is within actually one service, so to speak, one microservice, so nobody's going to be really panicking, because you can, within your domain, you can maybe fix it. The other pieces I want to highlight because often we're just watching what's coming in, right? We don't necessarily watch, should it be higher, right? Is somebody not talking to us, or something happening up front? And it's just, hey, let's just be good neighbors. Go ask somebody, is something going on? They might not know. They might have so much on their plate, and they just don't know. And literally, we have issues like that. It's some obscure bug, and you would actually see the results later on in the chain, in the business domain. So like, what if we work together and show people that? So let's do something else, and we can also pretend it's deploying. And then, okay, I don't want to create too much noise. Theoretically, you can decide what to do, but this is just sort of blinking. Theoretically, you can also, it's deploying and warn everybody up front something's happening. But if you're in the cloud and you're using autoscalers, regardless of whether, or you're just using serverless and the cloud does everything for you, nobody should really notice, right? If you're doing proper blue-green deployments. That's also a lot harder, and people don't talk enough about that. But you shouldn't really notice that something's happening. So that's all I want to show for the demo. So let's go back. Now I have to find my window and move it back there. So I want to wrap up the message that I want to try to give to you guys in this talk. Remember, the first one was that microservices are complex and not perfect, right? And the reason for that, again, is because we're complex and we're not perfect. We're diverse. The second thing is sort of computers are useless. They're useless because they only give you answers. So really, it's another way of saying the problem starts with us. Make sure you're actually asking the right question before you start automating the shit out of everything, because you may be automating the shit out of the wrong thing. That's what I want to say. Yes. So I also want to say open source. I really like open source. And even though I worked for sort of an enterprise, like, okay, let me just do this on the side, and I want to make sure everybody has this. And it doesn't matter if you're on Google, AWS, or Azure. There's this really interesting graphic here. And it's from the VP of Facebook, VP of product. And initially, the original graphic refers to what is a junior designer. And the junior designer takes something that's sort of chaotic and makes it ordered. Looks nice, right? What I want to challenge you guys to do is create new value. A senior designer is maybe somebody who sees something that's not there, or that's not obviously there. Take everything into account and ask questions, because then you maybe are creating something new that brings value that wasn't there before. That's it. So, yeah.